So we want to solve the following second order differential equation. We want to find the particular answer for this equation. In order to do so, we want to first find the homogeneous answer. Then we want to find the particular answer as well. And we just combine these two answers together to find the particular solution for the general format of the equation. So to find the homogeneous answer, we're just gonna say f of x would be equal to 0 in this case. And we are gonna say that the characteristic equation would be equal to m to the power of 2 minus m minus 6, which would be equal to 0. We know that the general format for the homogeneous answer would be equal to y is equal to e to the power of mx. So I just substituted this value onto the second order differential equation. And after substituting and just dividing the term of e to the power of mx by both sides of the equation, it would give me this characteristic equation. And this one would be equal to, if you actually factorize it, it will be equal to m minus 3 times m plus 2 equal to 0, which would give me two m values, which is m equal to 3 and m equal to minus 2. That means our homogeneous answer would be equal to 3 times e to the power of, it would be a times e to the power of 3x plus b e to the power of minus 2x. Because we find the m values in here and we just substitute the m values into this equation which we had earlier, which was e to the power of mx, and we just use the linear combination and combine these two answers together to get the homogeneous answer. Now for the particular solution, we're just gonna say that if the function is e to the power of minus 5x, our particular guess and particular solution would be equal to a times e to the power of minus 5x. And we're just going to use this guess and put it into the second order differential equation to get the a value. So what I'm going to do, I'm just going to substitute it. What is the second order derivative? What is the second derivative of the e to the power of minus 5x? It would be a times 25 times e to the minus 5x minus, what is the first derivative of this one? It would be a times minus 5 e to the power of minus 5s. We just did this based off the, we just did both of them based off the chain rule. Based off the chain rule, we just first take the derivative of the power, which is minus 5x. What is the derivative of minus 5x? It is minus 5, and just bring it out in front of the equation. So the first one would be minus 5 times e to the minus 5x, and if you actually take derivative in the second time, it would be minus 5 times minus 5, which would be equal to 25, which I wrote in the first equation. And the last term, we have minus 6y, which is minus 6 times a times e to the power of minus 5x, which would be, this value would be equal to our f of x, which is e to the power of minus 5x. Now, since e to the power of minus 5x is not equal to 0, I just can divide both sides of the equation by this value. So e to the power of minus 5x would be actually omitted in both sides. So I just write 25a plus 5a minus 6a would be equal to 1. And that would give me a is equal to 1 over 24. And I can also write my particular solution for the non-homogeneous one would be equal to 1 over 24 times e to the power of minus 5x, right? Now, I got my two solutions in here, which was the homogeneous and the particular one. Now I'm just gonna write the general solution, which would be equal to a e to the power of 3x plus b e to the power of minus 2x plus 1 over 24 e to the power of minus 5x. Now, if I can find the a and b values in here, I can get my particular solution for the general solution. So actually my answer would be defined. Now, in order to find the a and b values in here, I'm just going to use the initial conditions mentioned for the question. The first initial condition is that when x is equal to 0, y would be equal to 25 over 24. So I'm just going to substitute x of 0 into this equation. That would give me a times e to the power of 0, which is 1, plus b times e to the power of 0, which is 1 again, plus 1 over 24 is equal to 25 over 24. That means that a plus b is equal to 1. So now I'm just going to use the second initial condition as well, which is given by y prime of 0 would be equal to 7 over 24. So I'm just going to take the first derivative of the equation, which would be 3 to the, for example, the first term would be 3 times a e to the power of 3x. And when I actually substitute x of 0 into the equation, it would be 3 times a e to the power of 0. So I'm just going to write 3a in order not to waste time. And for the second one, it would be also minus 2b. And for this one, it would be minus 5 over 24, which would be equal to 7 over 24. Now, what I can now write is 3a minus 2b is equal to, I'm just going to move minus 5 over 24 to the right side. So it would be 12 over 24, which would be equal to 1 over 2. Now, I'm just going to find the a and b values in here. So what I can do is I can actually multiply the first equation by 2. So it would be 2a plus 2b is equal to 2. And the second one is 3a minus 2b is equal to 1 over 2. Now I can just add up these two equations and my b value would be omitted and I will be left with a only. So I can calculate a. So if I add them up, it would be 5a is equal to 2 plus 1 over 2, which is 5 over 2. So that means my a value would be equal to 1 over 2. And if I substitute a is equal to 1 over 2 into either of the equations, I'm just going to use the first equation, for example. It is 2 times 1 over 2 plus 2b is equal to 2. So I'm just going to say 2. I'm just going to write it below. So I'm just using this one in here. I'm just substituting a is equal to 1 over 2, which is 2 times 1 over 2 plus 2b is equal to 2. So this one would be 1. And 2 take away by 1 is equal to 1. So b is equal to 1 over 2 as well. So I got b and a values in here. Now, since I got my a and b values in here, I can just rewrite the equation again. So I just can say that my particular solution for the general formula is now 1 over 2 e to the power of 3x plus 1 over 2 e to the power of minus 2x plus 1 over 24 e to the power of minus 5x. And that would be my particular solution for the general formula.